Hello, everybody. Today we are going to do an introduction on biodiversity. So this is something that came up in our first little pre-unit. So now we're going to get into some of it. Some of the essential knowledge. So just kind of, you can think of this as takeaways that you should get. Biodiversity in ecosystem includes genetic species and habitat diversity. Species richness, so refers to the number of different species around the ecosystem. The more genetically diverse a population is, the better it can respond to environmental stressors. The ecosystems have large numbers of species are more likely to recover from disruptions, and that loss of habitat leads to the loss of specialist species. So all of those things. So what is biodiversity? This was something that came up in one of the first set of notes that I did. And some of you were a little confused about it, and that's okay. So what biodiversity is it's a kind of a multiple component thing where you're taking the number and the variety of populations in a species. And this just equates to the species diversity. So how diverse is that species group? You can have differences in genetic diversity of those populations. So that can be one thing. And the ecosystem and habitat diversity that's necessary to house those populations. So if you have a really big biodiversity, you're going to have different habitats and different ecosystems that are going to need to house those populations that they all have to fit into. So species diversity and our focus. So there's two components. There's species richness, and species richness just means the number of species. Simply that. So if you go into say we go into a field and we find 7 different species of grasshoppers, well, that's our species richness is 7. And then species evenness. So how evenly distributed or how distributed are those species? And the greater that this evenness is, means that those populations have a similar size. So there's not like a big drastic ballooning population of one species and a really small one of another species. So when we do this and when we measure these species of diversity, and this is something that we're actually going to do in class in 2 different ways, we have some assumptions that we have to make. One, we use the same techniques in the 2 habitats. So if we are gathering data from one place, we want to make sure that we do it in the same way in one area as we do in another area. We don't want to use different ones. And we want to make sure that we're comparing similar types of organisms. So we don't want to go to one field and look at mice and another field and look at the bird species or the hawk species. It just doesn't make sense. It's that old adage, comparing apples to oranges. We don't want to do that. We want to make sure that we're comparing similar species to one another. And there's 2 methods, that species richness, which I talked about, and Simpson's diversity index, which is is more math-based. So species richness, like I said, it's pretty simple. So the formula is just R equals S. So your species richness, or R, is equal to your number of species. So again, in the example that I used, if you go out into a field and you find 7 different species of grasshoppers, well, your species richness is 7. Or the example here, you find 3 different species, well, your species richness is 3. So species richness is pretty clear-cut, not too much on the math side. Just have to make sure that you count the species up right. So identifying the species is important for our species richness. The Simpson's index of diversity is a little bit more complicated. So this is a measure of probability. So the formula that you use right there, so D, or the diversity or Simpson's index of diversity, equals 1 minus the sum of n initial, so your number of species, divided by your total number of species, and then you square it. So like I said, D is the Simpson's diversity of index value, I is one particular species, N is the number of the given species in I, and N is the total. This can be a little daunting, but like I said, we are going to use this in a couple different ways in class. One to kind of get you used to it, and then another one that will be kind of a broader study that we're going to do in this unit. And for the Simpson's index of diversity, the range that you're going to get is between 0 and 0.999. And the higher you are on that end, the more diverse the area that you're looking at is. So we have an example here that we'll run through quick. So say that we go and we collect a survey and we have 20 of species A, 25 of species B, and 5 of species C. When we add those all up, our N is going to be 50. So we'll keep that in mind as we go through. So when we set it up, we have D equals 1, so that'll be the same. Remember that this sign means the sum of, so you can do all of these individually and then add them up at the end. You just have to make sure that you add them up. So here we have our 20, so we'll do 20 divided by 50, square that, plus 25 divided by 50, square that, and then 5 divided by 50 and square that. So what they did here is they just wrote it all out, made sure that they added them all up, and then simplified them here. So you simplify those, so 0.16, 0.25, and 0.01, add them up, and minus, and so then take 1 minus the sum of all of those numbers. So in this one, we get 58, or 0.58. So diversity-wise, it's kind of in the middle or average for species diversity, and that's okay. That's what we're trying to find. So instead of just saying how many species, how well distributed are they? So in this one, we have a really large number of these two species that are pretty even, but this number is way low. So that's going to kind of pull down the rest of that number. And this is just a real simple example. We'll do more, and you'll get a chance to manipulate those numbers because now we're getting into the math heavy stuff. Yeah, that'll do it for today. Hope you all have a good rest of your day. Bye.